So let's start with the sixth tutorial, which is the last one in Python. Now here again we are going to understand some more instructions of sequences and file operation in Python. So Python sequence is the generic term, as we have seen earlier also, and for an ordered set and list are the most versatile sequence type. Now Python supports a variety of operations applicable to all sequences, including strings, lists and tuples. We have learned list, tuples, etc. in the earlier tutorials. The same is now we are trying to understand in little more detail. Some sequence operations apply to all containers, including, for example, sets and dictionaries, which are not sequences, and some apply to all iterables, meaning any object on which you can loop, as covered in the iterables. The sequences in general are containers with items that are accessible by indexing or slicing. You can index or you can slice also. That means you can select only one or two or as many characters as you want from that particular string. So the built-in len function takes any container as an argument and returns the number of items in the container. The built-in min and max functions take one argument, a non-empty iterable whose items are comparable, and return the smallest and largest items respectively. Now some IO functions, printing screen, that we have seen already in the last tutorial, that how you can display or print something on the screen by writing a proper function, and the same thing has been depicted here again so that we can recall and re-establish ourselves. So this produces the following result. As we have seen, Python is a really great language, isn't it? And some more kind of a repetition on that. Python provides two built-in functions to read the line of text from standard input, which by default comes from the keyboard, like raw input or whatever. So you can use the input function for various purposes, for inputting the data into your screen, and then of course whatever further action you want to take, whether you want to store it or you want to do some kind of action on that, whatever you want to do, that can be done by writing appropriate code for that. Like opening a open function, where you want to open a file or a data file or whatever you want to have. So you have to open it by using Python's built-in open function. This function creates a file object which would be utilized to call other support methods associated with it. Now file object is equal to open file name, access method that you have to describe, and then buffering if it is there. Similarly, in the file name, access mode and buffering, whatever we have seen, the same thing is applicable, and we have to use it as and when we need. But we must use if it is there, if you know it and if you need it. Similarly, those different kinds of opening functions of files, that is R, how to open that using R function, or RB, that is binary data or binary format, R plus, RB plus, W, WB. So like that, those functions that we have discussed, similarly we can by reading this and understanding it properly, we can use it wherever we need. But it is very useful so that you can decide as to what for you want to use that particular data file, whether reading or writing or both, or appending only, or appending plus binary file, or whatever. Now let us talk about the exceptions handling. Now exceptions are very, very common. You will see that whenever there is any minor or bigger error is there, it will throw a kind of an exception, and the program should be sufficient enough to handle the exceptions, because these are something which not knowingly, sometimes by mistake you just built into your program, and when you execute that program you will face this kind of a problem. So you must be able to take care of those kinds of exceptions which may occur without your knowledge. So Python exceptions can be handled using a try statement. You can use a statement called try. The critical operation which can raise an exception is placed inside that try clause. Now Python provides two very important features to handle any unexpected error in your Python program and to add debugging capabilities in them. Exception handling. Here is a list of standard exception available in Python. Standard exception. Now the exceptions are like the exception description is also mentioned here. Base class for all exceptions. Now spot iteration raised when the next method of an iterator does not point to any object. System exit raised by the sys.exit function. Standard error, base class of all built-in exceptions except stop iteration and system exit. Arithmetic error, base class for all errors that occur for a numeric calculation. Overflow error, based when the calculation exceeds maximum limit for a numeric type. So like that, now in this case you will see that the floating point error raised when a floating point calculation fails. Zero division error raised when the division or modulo by the zero takes place for all numerical types. Assertion error raised in the case of failure of the assert statement. Attribute error raised in case of failure of attribute of reference or assignment. End of file error raised when there is no input from either the raw input or the input function and the end of file is reached. Import error raised when an import statement fails. Then the next is keyboard interrupt raised when the user interrupts program execution, usually by pressing Ctrl C. That means you want to abort. Lookup error, base class for all lookup errors. Index errors raised when an index is not found in the sequence. Key error raised when the specified key is not found in the dictionary. Name error, you can see that whatever error comes, it is an explanation and why that error has arisen, and you must be able to take the corrective measure for that. Name error raised when an identifier is not found in the local or global namespace. Unbound local error is raised when the trying to access a local variable in a function or method but no value has been assigned to it. Now these are very common types of error which you will face when you start writing your programs and execution of that program takes place. Environment error, base class for all exceptions that occur outside the Python environment. IO error, raised when an input-output operation fails, such as the print statement or the open function when trying to open a file that does not exist. Then it gives you IO error. And it also gives IO error raised when the operating system related errors may occur. Syntax error, that is very common, raised when there is an error in the Python syntax itself. Indentation error, raised when indentation is not specified. Python is very particular about the indentation. So in case it needs 4 spaces from the beginning, you must give the specified number of spaces. Nothing more, nothing less. So it will immediately give the indentation error. Similarly, the system errors raised when the interpreter finds an internal problem. But when this error is encountered, the Python interpreter does not exit. It remains there. Then system exit raised when Python interpreter is quit by using the system exit sys.ext exit function. If not handled in the code, cause the interpreter to exit. So that is why it is important that whenever, whether that error occurs or not, you must take the corrective measures in your program so that in case it happens, you are in a position to take care of that. Type error raised when an operation or function is attempted that is invalid for the specified data type. Value error raised when the built-in function for a data type has the valid type of the argument, but the argument have invalid values that is specified. Runtime error is also quite common because raised when a generated error does not fall into any category. Not implemented error raised when an abstract method that needs to be implemented as an inherited class is not actually implemented. So this completes your IO operations and of course your Python tutorial. Thank you.